Algebra students, we're going to do the notes for section 3 today. We're going to start with some vocabulary first, so find section 2 of the vocab in your note packet. We're going to start with some definitions we discussed yesterday. Our first is a linear function. So remember, this word linear indicates that it's a function that when we graph it, it's going to create a straight line. And we said a linear function can always be written in the form of y equals mx plus b. Yesterday, we also learned about discrete and continuous domains. Remember, we said that discrete domains are ones that, discrete domains only contain certain values. Continuous domains are domains that contain all real numbers in the solution set. So here's our new vocabulary today, and this is what we're going to cover in section 3 is function notation. I'm not crazy about this definition of a fancy way, but basically this part is true. It is something that gives you a rule to follow. Okay, I'm going to pause and move to section 3 of the notes. All right, so please make sure you're on section 3, function notation, and this is what we're going to discuss today. So far we've been looking at equations in standard notation, which is our y equals mx b. Function notation is when you take the y and you replace it with f of x. So one really key idea to think about in this section is the idea that this expression, f of x, is just replacing your y. So f of x is equal to y. Notice it doesn't change the rule for the function. Okay, and just also keep in mind that f can be replaced by other variables, like you'll often see g of x, h of x, okay, or a couple of other variables in place of that. So let's talk about what this means. So in the first notation, this means when x equals 2, so it says f of 2 equals 14. So when x equals 2, the value of the function is 14. Okay, same thing. Here's that new variable. So this one just says g of negative 2 equals 24. So this one just means when x equals negative 2, the value of the function is 24. Okay, and then this last one is a little bit different. So notice we don't get a value for x. So this is something we're going to do later on in our lesson. So when x is not there, it means find the value of x. Okay, so we're going to be looking for x, find the value of x when the function value, or when, I'm going to say when the value of the function is negative 9. Okay, so before we move on, it's also important to recognize, again, that x being our input variable and y is our output variable. Okay, so when our input is 2, our output is 14. So one thing I also want you to recognize is what we're also getting, one advantage of using function notation is we're getting some ordered pairs that will show up on this line if we were to graph it, which we will do in later sections. So 2, 14 is the solution of this function. Okay, same here, negative 2 to 24 is the solution of this function. So that's an important connection to make. Okay, we're going to go ahead and move on to the next set of examples. This time we're evaluating our function given some specific values. So it says evaluate the function when x equals negative 4, when x equals 0, and when x equals 2. So what that means is that you put negative 4 in place of x, and you just evaluate the function using order of operations. So the way we write that using function notation is we say f of negative 4 If you need to show some work, you can do this. You can say negative 4 plus 4 is 0. This part, I guess, could typically be done in your head if at all possible. So basically, we're saying f of negative 4 equals 0. Ooh, and actually, that is not true because I just need to ignore the sign there. So we need to fix that. Okay, be really careful about that. This is the opposite of x. So if x is negative 4, and it's the opposite of negative 4, which is 4 plus 4 is 8. So f of negative 4 is actually 8. So that's why it is sometimes helpful to write out your work. Okay, the second one is f of 0. So when x is 0, there is no opposite of 0. So it's just 0 plus 4 is 4. And then when our function value is 2, negative 2 plus 4 is 2. So f of 2 is 2. And then we're going to do the same thing with these as well. So g of negative 4 would be 5 times negative 4, which is negative 20. Okay, our second value would be g of 0. 5 times 0 is 0. And then g of 2 would be 5 times 2, which is 10. Okay, how about you try number 3 and you go over them together as a class? Okay, pause the video if you need to. I'm going to go ahead and move on to number 4. So this one says, find the value of x. So this is what I was talking about earlier when you have this notation b of x equals negative 20. So it means when the function value is negative 20, find the value of x. And up here it's telling us that the function b of x is equal to negative 3x plus 1. So we want to know what is the value of x. If our function is negative 3x plus 1, what is the value of x when the function value is negative 20? So you set those equal to one another, and then you just solve using your equation work. So negative 3x is equal to negative 21. Divide both sides by negative 3. So therefore, x is equal to 7. So you would say b of 7 equals negative 20. Okay, we'll do that one more time with number 5. Let me scoot a little bit so I can have some more room to work. Okay, so this time it says the function r of x is equal to 4x minus 3. What is the value of x when the function value is 33? So you put 33 equal to 4x minus 3 and solve. So add 3 to both sides. 33 plus 3 is 36. Divide both sides by 4. So x is equal to 9 here. So we would say r of 9 is equal to 33. This is plenty right here. Sorry, this one was 7. Okay, so go ahead and keep moving. We're going to move on to the next page and look at some additional examples. Okay, let's see. Actually, I'm going to leave these for you guys. These are going to be on your own. So I'm going to keep moving in the notes. Sorry about that. Okay, so just mark these as on your own. You're going to do 6, 7, 8, and 9 on your own. If you have time to check them as a class, that's great. If not, we'll go over those tomorrow. And then move on down to where it says teacher guided notes, and we're going to look at this. So this is applying our function notation to a real life situation. So it says let n of t be the number of DVDs you have in your collection after t trips. Okay, so you see how t is right here, and we're saying t is the number of trips to the video store, and then it's going to represent the total number of DVDs, which is this number here. So in order to explain what that means, you just have to interpret the vocabulary. So this means if, let's see, if I make 0 trips to the store, I have 8 DVDs. Okay, so basically that means I own 8 DVDs, whether I go to the store or don't go to the store. I have 8 DVDs already in my collection. Okay, so number 2, n of 3 equals 14 means after 3 trips to the store, I have 14 DVDs. Write that down. Okay, number 3 is a little bit different. So notice this time we don't have a total number of DVDs, but it's saying, this one says after 5 trips to the store, I have more DVDs than I had after 3 trips to the store. Write that down. Okay, and this last one just means if you subtract the number of DVDs from after 2 trips from 7 trips, you'll have a total of 10 DVDs. I'm going to abbreviate here. Okay, go ahead and pause the video if you have any questions or need a little bit more time writing. I'm going to continue to move on. So in this next set of examples, what we're going to do is graph the linear function. Okay, so this is not too bad. We're given some function values. So notice here's my function rule, s of x equals 1/2 x minus 2. And then they're telling me that these are the values of x that I want to plug into my function rule. So again, I'm just evaluating that. It's like an input-output table. So when x is -4, half of -4 is -2. -2 minus 2 is -4. Half of -2 is -1. Minus 2 is -3. Half of 0 is 0. Minus 2 is -2. Half of 2 is 1. Minus 2 is -1. Half of 4 is 2. Minus 2 is 2. Okay, and from there, I just go ahead and plot those points on my graph. So -4, -4, -2, -3, 0, -2, 2, -1, and 4, 2. Okay, double check and make sure that those points should be in a linear path. Double check and make sure that I didn't make any mistakes there. I'm going to skip number 13 and continue moving. Okay, we're going to look at this application problem is pretty important. So it says you have this function over here, b of m equals 50m plus 150. And then you have this information about your friend's savings account, and they want to know who has the better savings plan. So probably the way I would do this is just go ahead and make a table of values for me so that I can, so if this is mine, I'm going to take this given function. I'm just going to make a table of values for me so that I can look at this and compare it to my friends. So I'm going to do 2, 4, 6 as well for my month. And then for my balance, I'm going to use my function to figure that out. So 50 times 2 is 100 plus 150 is 250. 50 times 4 is 200 plus 150 is 350. That didn't show. And then 6 times 50 is 300 plus 150 is 450. Okay, so I can see here what I want to do is look at my rate of change. I can see that I'm increasing by 200. That does not look right to me. Okay, so apparently I can't add, and I need to fix this. This would be 250, which makes this plus 100. So I'm adding $100 every 2 months. I'm adding 100. If I look at my friend's account,